Welcome, GeoTrig. This is section 1.8, perimeter, circumference, and area. The essential question is, what is similar between area and perimeter? What is different? Let's begin. I think this unit's going to be a lot of review, so write down what you need to, but let's go through it. Perimeter is the sum of lengths of sides of a polygon, and the area is the number of square units a polygon encloses. So the perimeter is the length around the side, so all around this polygon. The length of those sides is the length. The area is the number of square units a polygon encloses. So it's the area inside the polygon. All of this, and I'm coloring inside the lines perfectly. So one thing you want to notice with the area is when we're talking about units, they will be square units, like inches squared. And perimeter is just going to be units like inches. So there's a difference there, inches and inches squared. Make sure you label units correctly. So here's some common shapes in their formulas, the perimeter and area. So we got a square, and what's a square? Well, all the sides are the same length, so I'm putting one dash on all sides to indicate they're the same. And each corner is a square root, or a right angle, so they're all 90 degrees. I'll put that little square there. The perimeter is, add the four sides, and the area is one side squared. So one side is s, 4s, and area is s squared. A rectangle, well, it's got two long sides, and then two other sides that are a different length. So I'm going to put one hashtag in two, and two hashtags in the others to indicate they are different. Alright, the perimeter is add up all the sides, and let's call this, we can call this side base and this side height. So you just add them all up. And the area is base times height. You might also call this length times width. That's what might be used to. But it's one side times the other. The triangle. So let's label these sides. This is side A, B, and C. And we have, I'm going to draw a dotted line to indicate the height. This dotted line is the height h, and this forms a right angle right there. So that's how you find, and the base is also, well, this is also, let's call this C. Let's call this C, and let's call this B. So the base. So the perimeter is adding up all the sides, A plus B plus C. And the area is 1/2 times the base times the height. So you take the base of the triangle and the height of the triangle, multiply those, and you get the area. The circle, so this point's in the center. Circumference of a circle, this is the perimeter, also called the circumference, is 2 times pi times the radius. What's the radius? It's the length from the center to an edge, and we'll call that r. So 2 times r. Now, you could also call this the diameter times the radius times pi, which is diameter is 2 radius, or radii. The area of the circle is pi r squared. So there you go. Alright, so we're going to do some examples of actually applying this because I think you can calculate the area of simple objects. So what is the boundary of the outer, what is the area of the outer boundary? So this is this area I'm filling in right here. So it's like we created like a little potted plant area. We want to find the area of this boundary right here. Well, we have a rectangle inside a rectangle. So what we're going to do is figure out the rectangle of the overall big one and then take out the rectangle inside. And that's our area. So looking at the dimensions right here, for this big rectangle, I know this length is 16. Let's clear all this mess. This length is 16, and each of these additional ones is 4. So this is 4 plus 16 plus 4. So the length of this outside is going to equal 24 feet. And the length of this side, well, we got 22 plus 4 and 4. So for this side right here, we got, label this in purple, this is going to be 22 plus 4 plus 4. So that's going to add up to 30 feet. So for the big rectangle, I'm going to call it the big one, equals 30 times 24. And that's going to equal 30. That is going to equal to 720 feet squared because it's area. So the inside, we'll call this the inside triangle, rectangle. Well, it's 16 times 22. So 22 times 16, what does that come out to? Do my multiplication. 2 carry a 1. So 13 and 2. That adds up to 352 feet squared. So to find the overall area of the boundary, it's going to be 720 minus 352. And this comes out to 6 and 3. 368 feet squared. That's our area. Let's try another example. We got a triangle in there. What is the area addition postulate? So this is another postulate for geometry. The area of a region is the sum of the area of its non-overlapping parts. What does that mean in English? We can take a figure and we can chop it up into parts to figure out the total area. So what is the area of this figure here? Now, we're going to look at what we know about this. We know we have a few sides that are all the same length and they're all 3 centimeters. So this side, this side, this side, this side, this side, and this side, because they'll have 1 tick mark. The other 2 sides are 9 centimeters. Actually, let's just label these. Why not? It's easy to label this. Just put 3 all around. So, well, how do we want to break this up? Well, let's see. I know if this side is 3 and this side is 3, I can cut this off right here, and we've got a square. So this one, we can figure out the area of this guy here. I'm going to call this area A. And then I can cut off this one too, because I know the length of this side's got to be 3. Well, yes, I do. And then the length of this side right here, well, if this part's 3, then this part's here got to be 6. So let's call this area B. And this last part, let's call it area C. So for A, that's going to be 3 times 3. It's going to be 9. For part B, it's going to be 6 times 3 is 18. And part C, it's going to be 9 times 3 is 27. So we add all those up, and what we're going to get is 9 plus 8 plus 7 is 24. Carry a 2. And we get 54 centimeters squared because it's area. So all you have to do is break it up into parts. Alright, I want you to try this one. What's the area of this figure? Pause the video. Let's try this out. So, oh, none of it's labeled. Alright, try this out. Now pause the video. Okay, what is the area of this figure? Well, we're going to break this up into parts again. Now, here's a neat thing. This breaks up into a rectangle right here, where I have we'll call this area A. And on top here I got a right triangle. Well, the right triangle, I know the height of this is 4. I'm going to label all these little parts. These are all 4. So let's do the area, and we'll call this area B. So the area of area A is the length times width of the rectangle. So it's going to be 4 times 12, which is going to be 48 feet squared. Now the triangle. So here's the thing. If I know this height's got to be 4, and this base, well, if this chunk here is 4, the rest of this has to be 8. So for the area of part B, it's going to be 1/2 times the base, which is 8, times the height, which is 4. So 1/2 times 8 times 4. 8 times 4 is 32. Half of that is 16 feet squared. So adding up 48 plus 16, you're going to get 4, carry a 1, 64 feet squared. There's your answer. I'll pause. 3, 2, 1. Okay, so what's the perimeter and area of this figure? So the perimeter, let's figure this out first. I'm going to count the length of the side. This is length 6. This side is going to be length 2. This side is going to be length 4. And well, what's this? We've got to use the distance formula to figure out the length of that line. So distance equals the difference of the x values. And let's label these points. This is -3, 1. And this point here is -1, -1. So the difference between the x values squared, so -3 minus -1 squared, plus the difference of the y value squared. 1 minus -1 squared. So 3 minus -1 is going to become -2 squared. And this is going to be adding, what's that going to be? Plus 1, so that's going to be 2 squared. So that's going to be 4 plus 4, which is going to be square root of 8. So D is going to be square root of 8, which is, we're going to round that to about 2.03-ish. We'll call it that. Okay, we'll say it's 2.3. So the perimeter, let's say 2.3, is going to equal 6 plus 2 plus 4 plus 2.3. So that comes out to about 14.3 or so. So let's try the area. Now the area of the figure, well, we got to break this up. We can break this up into 2 chunks right here. So I'm going to call this part part A and this triangle part B. Part A, this is a rectangle. It's a 4 length times width. So part A for the area is going to be 4 times 2, which is going to be 8. So for part B of the area, it's 1/2 times the base times height. So 1/2 times the base, we'll call this side the base, call this side the height. The base is going to be 2 units, and the height's also 2 units. So my area of that is going to be 2 blocks. So the total area is going to be 8 plus 2, which is going to be 10 units. That's my area. Okay, last example. Pause the video. Okay, you got to find the area of the shaded region. So it's like the outside square going on right here. Well, all you know is that the radius of this circle inside is 4 inches. So, well, what you can do is you got to figure out the area of the square and subtract that inside the area of the rectangle of the circle. And that'll give you a total area. Well, what's the area of the square? Well, I know if my radius is 4, that means the diameter D is going to equal 8 inches. If diameter is 8 inches, notice that the diameter is the same length as one side of the square, because it goes straight up and down here. So that means each side is also 8 inches of the square. So it'll be 8 times 8, or 64 inches squared. Now, area of the circle. Area of a circle is going to be pi r squared. The formula is pi r squared, and the r is 4, so it'll be pi times 4 squared, which is going to be 16 pi. So that's 16 pi inches squared. So your total area is going to be 64 minus 16 pi. What is that? I don't have a calculator on me, but it's that in inches squared. All right, that's it.